Okay, so this is the last session in this lecture where I'm going to show you some symbols and examples of geometric tolerancing. Geometric tolerancing. First, you've seen some of these symbols before in previous sessions, uh, but here is like this table. This table shows the symbols for geometric characteristics. Again, just to remind you, and you should familiarize yourself with these kind of symbols like straightness, flatness, roundness, cylindricity, line profile, surface profile, parallelism, perpendicularity, angularity, line profile, surface profile, position, coaxiality, symmetry, uh, line profile, surface profile for the location. Um, um, in here, these two require line profile and surface profile. Here they require a reference, they require a datum, but these two, it's in the form tolerance. They do not require datum. So and circular and total runout. So based on the BS8888, there is a huge table which is shown in figure 124 uh, that shows you these kind of geometric tolerancing with like nice explanation. So you are just advised to go to those tables and read carefully, or I've just put like some snapshots here as well, so you can just read from the lecture notes here. Um, so the first like feature control frame here is about straightness tolerance. So if, for example, in the one of the drawings you have seen this symbol, so you should be able to understand what does it mean. So first we have this surface here as the datum A, which is the main datum, which obviously is the front surface here, because this is a side view. And it shows you here, it says that the tolerance, the straightness tolerance of this surface should be within 0.1. And this part is attached to that, says that it should be parallel to datum A. This here shows you some details. So we're talking about the straightness of this line here, okay, or this edge. And the meaning of this feature control frame means that if this is this surface here is datum A, small a here means datum A, which is obviously this surface. It here says that if you at any distance b, you create imaginary plane C. So this plane here should be parallel to A. So parallel to A here means that the plane that you are gonna create here, or the imaginary plane, should be parallel to A. Okay, so we're done with this part. Then the straightness of this edge should be within 0.1, meaning that in here for this edge, if you draw two lines, let's say one above and one below, and the distance between these two lines, which is this line here and this line here, the distance between these two lines is small t, where the t here is the tolerance, which is 0.1. So this edge here can take any shape. So the dashed solid line curved edge here it's exaggerated, but it says that as long as the edge is between or within this tolerance, so it will be acceptable. So this could be like a straight line connecting running from here to here, or a straight line running from here to here, as long as it is within this tolerance, so it will be acceptable. And this shows the straightness of, or the straightness tolerance of an edge. Again, what if you have a cylinder? And this symbol here, the feature control frame shows that it says that the straightness of this surface here should be within 0.1. For a cylinder, what you do, you just imagine that you have a plane, and this plane uh, goes just um, is parallel or goes through the center line of the cylinder, and then above and below this surface you draw two lines. The distance between them is small t, which is the tolerance 0.1, and then you say that the surface here, the edge or the top surface here, uh, should be, or must be within this tolerance. So it can have any shape. So the dashed solid line here shows you that it is, of course, exaggerated, but it says that this surface here, top surface, can have any shape, but as long as it is within this tolerance zone, so it should be accepted. Um, Sometimes they can define this as phi 0.08. So the feature control frame here says the straightness of it is attached to this dimension here. So it means that we are talking about the median line here, or the center line, because this one is attached to the surface. So we were talking about the surface, but this feature control frame is attached to the dimension. So when it is attached to the dimension, we are talking about the median line of this dimension, which in this case is the center line. So the difference is that this is here given as phi 0.08. So it just means that let's read this because this is quite important. So the tolerance zone shall be limited by a shall be limited by a cylinder of diameter d. So we should have a cylinder with a diameter d here, and it goes with the same length as the real cylinder that we have here, where T here is the tolerance value preceded by the symbol D. So what does this mean? When you have this straightness of this median line, it should be within a cylinder of diameter 0.08. So the extracted median line, so this line here of the cylinder, this extracted median line of the cylinder, of the real cylinder, to which the tolerance applies shall be contained. So this line should be contained within this small cylinder with a tolerance D. So just imagine you are having another imaginary cylinder here that has the same width as this one, but with a diameter of phi t, which is quite small. Then this median line here should be within this diameter. So, for example, this dashed line here or dotted line here, it's an exaggerated line, but it says even if this line is having this shape, as long as it is within this cylinder, so it is acceptable. And this is what is meant by this phi 0.08. So when it says phi and then giving you tolerance value, it means that you should consider the zone, the tolerance zone, as a cylinder. Okay, but here we've considered this zone as two parallel lines because it's not phi preceded by a value or followed by a value. So the flatness of the surface here, it says the flatness of the surface should be within the 0.08 mel, for example. So what we do here, we just imagine that we have two surfaces here with like T value between them, which in this case is 0.08. And then the dashed one here is the real surface that we get after manufacturing, but the inspector should like either accept or reject this surface. As long as the surface is within this tolerance, it's between these two lines, between these two surfaces, it will be accepted. And this is the symbol of a flatness of a surface. So the roundness tolerance, so the roundness tolerance here is denoted by this circle. So it says that for this cylinder, the roundness should be within 0.05. So if you just imagine that you have a cross section, you cut through the cylinder that you have, and then it says here roundness should be within 0.05. So, and then imagine that on this line here, on this plane here, you draw two circles with a distance between them, the tolerance zone, it's 0.05. So the distance between these two theoretical circles is 0.05. And then the real cylinder that we get after the manufacturing, which is the line in between here, or the circle in between, could take any shape as long as it is like between these two circles with a distance between them 0.05, it will be accepted. So the cylindricity tolerance, the previous one we were talking about the roundness, so we are just having one section here in the cylinder, but here the cylindricity, we are talking about the entire cylinder in state. So it says the cylindricity here should be within 0.1. So what you do here, obviously you, so the tolerance zone should be limited by two coaxial cylinders with a difference of in radii of t. So we plot here two cylinders, and then the difference between these two cylinders is t, okay? And then the real cylinder itself can take any shape as long as it lies between these two theoretical cylinders. So this is the real cylinder. Then we plot like a theoretical cylinder, which is smaller than this one, another cylinder that is larger than this one, and the difference between these two cylinders is t, which is 0.1 in this case. And the real cylinder surface should be within this tolerance, okay? Surface profile, so in this case, we have a profile here, which is this symbol with no datum, means that this is the form tolerance. Then it says here the surface profile should be within 0.4, but it does not define any datums here within this feature control frame. So what we do here, we just plot two theoretical surfaces, and then we plot a sphere between them. The sphere diameter should be t, so S phi t means a sphere with a diameter t. And then the real surface, which is this solid black surface, should be anywhere between these two dashed theoretical surfaces. Here, the line profile. So in this case, so without this, if you compare this one to the previous one, if it has like this horizontal line, so it's a surface profile. We're talking about this surface to the surface. If you look from the top, you'll see like surface like this. But here we're talking about line profile, so it's only a single line instead of just entire surface. So it says here that, so without this horizontal line, it means that we're talking about like just a line profile instead of surface profile. It says here the tolerance zone should be limited by two lines enveloping a circle. So in this case, we have two imaginary kind of lines or curves. These two lines or these two curves are separated apart by a cylinder of diameter d. And then the real one, the real profile here should lie within these two lines. So the parallelism tolerance of a surface related to a datum line. In this case, here it says this surface is parallel to datum C. Datum C here is the median line for this dimension, and it should be within 0.1. So what we do here, we say, okay, this line here, the center line defines datum C, which is the center line here. And then at the top surface here, we plot two surfaces, one at the top, one at the bottom, and then the distance between them is t, and then the dotted line here shows you this surface, the flatness of this surface, and it could have any shape as long as it is within these two parallel theoretical planes. It should be accepted. Then the perpendicularity tolerance of a feature of size related to a datum. So if you see here, it says that the feature control frame here is attached to this dimension. So it says that if it is attached to this dimension, so it means that we're talking about the median line. So the median line here, should be perpendicular to datum A. So where datum A here is the bottom surface. So this is the bottom surface, for example, datum A, and then this median line should be perpendicular to this surface within phi 0.01. Again, once we see in the tolerance zone here, or the tolerance part here, phi, so we should straight away think about a cylinder of diameter 0.01 around with the theoretical center line here. So this is the center line. We should draw a cylinder around this center line with a diameter of 0.01, and we think of that this center line, the real center line, could be a little bit tilted to the left or a little bit tilted to the right, but as long as it is within this allowed cylinder or tolerance cylinder, we should be fine. It should be accepted. So you should think about two things here, a theoretical center line and a real or center line. So theoretical center line, which is the center line of this tolerance cylinder, and the real one, so after we just manufacture this part, the center line could be a little bit tilted to the theoretical one, to the left or to the right, but as long as it is within this tolerance cylinder, it should be accepted. And this is the symbol for the perpendicularity. Angularity, so something similar. You say here the angle of this surface is should be within 0.08 with relative to datum A. So if this is the bottom surface, which is datum A, and we have the angle here, so what we do above and below this surface, we plot two theoretical surfaces with a distance between them, which is 0.08 in this case, or t, and then the angle here measured from the datum, we say that, okay, so this angle is 40. It is boxed here, meaning that the tolerance is defined through the GT and T. And then we say that the surface could be anywhere between these two surfaces, theoretical surfaces, as long as it is between them, so it should be acceptable. So this line could be tilted a little bit above or a little bit below, but as long as it is within these defined surfaces, so we should be fine. And this is the symbol for the angularity. For position, so something similar, we say, for example, here, the position of this hole should be within phi 0.08 relative to datum C, A, and B. So we have three datums here. We have datum A, which is this face, datum B, which is this face, datum C, which is the bottom surface, which are shown here as well. But if you think about it, you say that the tolerance here is a cylinder with a diameter 0.08. This is the theoretical center line, which is this here, this center line that is going out of the page. And then the real center line could be, which is the exaggerated dotted line here, could be anywhere within this. It could be tilted a little bit to the left, tilted a little bit to the right, but as long as it is within this tolerance cylinder, we should be fine. And here it's perpendicular to C, so the the center line here, or the position of this one, is perpendicular to C, and it is defined by 100 mil with respect to A, and 68 mil with respect to B. But again, as I said, so as long as the center line that is going out of the page at this point is within this tolerance zone, so we should be fine. I don't want to make it very long, but I hope that you got the point now. So what I want you to do is like to just go through the rest of these symbols for the coaxiality, for example, for the symmetry, for the surface profile with datum, line profile with datum, for the circular runout tolerance, and the total runout tolerance. Please go through them, read it yourself, and you've got the point now. Once you grasp the concept, so it becomes easy for you to understand. So please just go through the rest of these, like 3-4 items remaining, and then try to understand them properly. Then the last thing that I want to talk about is the drawing checklist. So what you need to do here, just make sure that you read this for the general drawing or the assembly drawings. Make sure that you have covered all these. For the geometry details or the manufacturing drawings or the detailed drawings, make sure that you've just covered all these points. And these are the references that have been used. For example, you can use this link to download find it through our University of Birmingham library. You can just use this link to download the British standard BS8888, or try to find this book by Simons and Maguire, which is like based on this standard. Or you can use this ROIMEC website also to find some information about British standard PS8888. I hope that you've just have got some more information now, and you've got like a real understanding of how to use PS8888. I'm not claiming that I've covered everything. You still need to read a little bit more. You still need to go through the standard yourself and to read a little bit more. But at least this gives you like enough information for you to do your assignment. Thank you very much.